Good morning. This is Mike Masterson. I'm an automation specialist with the Reynolds Company out of Houston. And today's Tech Talk, we're going to be talking a little bit. We're doing an introduction to LogixAI. Just want to let you know we are recording this to post on our website. So if you, for any reason, you find this topic useful and want to revisit it, we will have it posted so you can go back and do that.
Okay. Good morning, everyone. This is Niraj Kacharia. Today's introductions. I am the presenter. I work for Rockwell. I'm the architecture and software business lead. We have our panelist team, Brian Mikeska, who is automation and network specialist in the Reynolds Company in Houston. Mike Masterson, he's the panelist also. He's the automation and network specialist at Reynolds in Houston. And Jesse Harvey, who is the automation and network specialist in the TRC company in DFW. Before we start on LogixAI, I just would like to remind you of the 2020 online events. There is an event coming up, user group, on Thursday, August 21, which would be focused on scalable compute and edge gateway. And on there's a TechTalk coming on August 25th. That would be focused on Innovation Suite, on FactoryTalk Innovation Suite, the ThingWorks platform. So let's dig into FactoryTalk Analytics LogixAI. When you come into the plant and you see this result saying, hey, production is down, what does that look like? What is the reaction? How does our team react? So reactive thinking, in a reactive situation, a great amount of time can be spent to pinpoint the problem. Right? Now, once the problem is pinpointed, then the right expert will have to do a deep dive. More time will be spent determining if the right tools and spare parts can be located to be used to reach a solution. This reactive thinking mode always leads to a conclusion that, hey, this has got to stop, right? Now, people have struggled to implement a proactive approach to this problem. Now, we can get a proactive approach with implementation of analytics. Now, what is analytics? Well, analytics in the simplest term means the discovery, interpretation, and communication of meaningful patterns in data. When we say analytics, we do not mean that it is MES or manufacturing operation management or batch or other operational processes that govern the process within the facility. When we talk about analytics, we are talking about the methods we use to measure our performance and then provide feedback in order to improve them. Right? So when we look at the Gartner model and superimpose with the ISA model, we can overlay the different kind of analytics on top of the levels within an enterprise, within a corporation. Right? We look at the device level. What are the device level analytics? And what is the descriptive analytics? The descriptive analytics provides you a simple description, right? For a motor, am I running okay or not, right? If the line is running okay or not, and what is the best plant performance? Right. Then there is a diagnostic analytics. Why did the fault happen? This is basically telling you the reason, the diagnostics. behind it. Why the line 1 quality is poor, or why is the site A throughput below the plan. Then we come into the predictive, and this is where you get the where we are starting to get more value. Right? On the predictive is on the line, on the device side, there is a fault that is going to happen soon, and the predictive analytic will actually tell you before it happens. On the line side, it is going to predict that line 1 is not going to meet the performance, or it's moving out of the tolerance limit. And on the enterprise level, that analytic can predict that does the plant or does that location meet the specific target for the month or for the year. And then we come into the most value on the analytics side is prescriptive. While on the predictive, you figured out that the fault is going to happen, but how do we resolve the fault before it causes a significant downtime? Well, prescriptive analytics will actually tell you that these are the actions you need to take, or what are the actions you need to take to resolve the fault before it creates significant downtime incident. So taking into consideration LogixAI module, where does it fit? What is its application fit? It fits in the predictive analytics for line level and the device level analytics. So it is close to the edge. It is actually on the edge. It is next to the control logics in the chassis. And it also provides you streaming analytics, so in real-time analytics. FactoryTalk Analytics LogixAI. A smart human is needed for success, right? A controls engineer knows the application, knows the control theory. Now, a control engineer who is working with PLCs does not have to know data science to be successful with LogixAI, because the modeling and monitoring that requires significant data science knowledge is automated within the LogixAI processor. A human will basically configure the LogixAI controls engineer. The controls engineer will identify the relevant data, right? And the controls engineer will identify when to train the model. The models are pre-built. The LogixAI pre-builds the model based on the data, right? And it also monitors that model changes. Now, a controls engineer will basically configure the system, identify the data. He will train the model and then integrate into the whole system for the feedback. Now, this is the value of LogixAI. It provides a predictive analytics without requiring a data scientist on the team to understand the model, to create a model. So how does it work? So, and where does it reside? It executes at the automation layer at level 1. It integrates into Studio 5000 environment. The UDT is leveraged to interact with LogixAI's module. We have a UDT built in, and certain UDT members, they drive action. So there are UDT properties that would drive action, while other properties would publish the results within Studio 5000 environment. So how does LogixAI, FactoryTalk LogixAI work? This is a screenshot of the LogixAI configuration screen. Like I said, you do not require data science. You require control engineering knowledge, integration with Studio 5000. You select the controller output that you care about. So you do have access to all the controller tags. You select those tags. You select the output from the LogixAI into the controller. Next, the user or you would select the tags in the controller that might be related to that output. A wide net can be cast. Pick anything that you think might be involved. The LogixAI is smart enough to do its own data cleansing, which basic data hygiene, eliminate all the data points that are not correlated to the output that you identified during the first portion of configuration. Now, if the data that you want to include doesn't exist as a controller tag, you will want to integrate that data as a controller tag, because LogixAI again is sits next to controller in the ControlLogix chassis. Once you have the inputs and outputs are identified and are selected, LogixAI will need to watch the operation running. So you would have, it will look at the streaming data coming in. Now this training period is unsupervised, meaning that there does not need to be a human being sitting and looking at this, whether it's working properly or not. You can just start the operation, turn on the training mode, and LogixAI will observe the data streaming through and see how those data points are related to the output that you have selected. So the actual predictive model building process is fully automated. Based on the amount of data that you are streaming through, LogixAI will rapidly formulate the theories of potential mathematical models from the observed operation. It will test each theory until itself is confident that the best possible physics-based model is selected. Right? The training time varies depending on the complexity of the operation. But in a simple process unit, we are talking about 20 to 25 minutes of unattended training. Now, some complicated process can take longer time depending on how many variables you have selected as input. For example, you can go up to 1 million variables or 1 million tags as input tags, and you can have one output from those 1 million tags. So depending on how many tags that you have selected in the beginning and how complex the process will be, it will take a longer time. For a very simple process unit, we're talking about 25-30 minutes of training time. Now, LogixAI will raise the bit in the controller to indicate that it is ready to begin predicting with more than 90% certainty. So once LogixAI knows that it has enough data to accurately predict, it will, like I said, create a bit, and that bit can be utilized inside the controller to engage its output in an automated fashion, or it can be, it can give a signal to a human being who's watching the operation. Now, if the controls engineer, or if you are ready to test it, you can monitor the bit in the control program also, and have an alarm or any kind of indication be generated based on the value. Now, how you respond to it, whether you want to put it in an automated algorithm within the controller, or you want to send out an email through SCADA systems through View SE, it is all a choice. You can wire that bit up to an output also, or to an alarm and event also. Now, if you have a higher level analytics system like FactoryTalk Edge, ML, or machine learning algorithm, and you want to send this output to that higher level analytics, you can definitely do that too. There are two modes of operation. Now, LogixAI's experience will be targeted to a controls engineer, someone who knows the application, but it doesn't need to be a data scientist. Now we'll start by identifying the tags and identifying the output. Now there can be various applications use cases. There could be a measurement of quality, scrap, throughput, flow. It's up to user to choose the value that matters for the prediction they want to build. But there are two modes of operations, right? Operational monitor and value estimation. What it means is operational monitor is monitoring and detecting the anomalies. And the value estimation means it's a soft sensor. What it means is in certain location, if there are sensor values are not reliable or the sensors are failing quite often, then you would need to estimate it. Or a location where there cannot be a sensor, say because of some physical issues. So on anomaly detection model, what are the use cases for anomaly detection? Well, there are three instances for anomaly detection. Anomaly happens and returns to normal. Then it is just a value in knowing it happened. Anomaly happens, system does not recover until correction action is taken. And then there is time in between before it can return to normal. LogixAI will help you cut down the time to resolve the problem. An anomaly is a gradual deviation over time and it grows. While in that instance, it helps recognize it in advance and can be related to time. In some applications, the model will be static and will not change. But in other applications, the model changes dynamically and the model will have to autocorrect and change over time, depending on the physical assets. It can be used for condition monitoring, root cause analysis, or to improve your already closed loop control schemes for better operations. Then we talk about the virtual sensing model, right? The virtual sensing operation. Now this operation also has about 3 different application use cases. Right? A sensor validation. So if a sensor is there and sometimes they drop off the reliability in connection, or if you want to predict a failure of sensor, then that would be sensor validation. We can use for quality assurance. If you are collecting quality data and you want to predict, if you want to predict what kind of quality a particular product will have based on the process it went through, it can be predicted. And also, again, it can be used to improve a control scheme. Again, if it's a closed loop control, adding a predicted sensor value in a closed loop control is always valuable from a perspective of control algorithms. So how does a virtual sensing, what is going on? Well, the sensor measurement, when we talk about the sensor measurement on virtual sensing, you can see that we had the points up to the sample 25, and then suddenly there are no sensor values. Right? When we apply the virtual sensing, we can see that below the line represents poor quality and action is required to remedy. Right? This is our quality metrics, but we do not have the sensor value. What do we do about it? Well, only the actual values can be used to make decision making. Now, what LogixAI does is it will provide the missing data points. And having those missing data points enables improved decisions. So that virtual sensing actually provides you the data points that can help you identify that the quality or the measurement over the time or the quality sample, where it stands without having a sensor or the sensor gone bad. Just a couple of applications where we have actually applied this LogixAI module in the industry. Now, condition monitoring example we have for blade dulling. In many manufacturing industries, blades are used for cutting operations, right? Now, when you are when automated with VFD, the blade dulling can be correlated with certain drive parameters. Now, a model was built to learn that physical nature of the process impacting the drive torque, and it resulted in anomaly detection when the blade is anticipated to be dull. Now, the proactive alert before the dull blade would cause any significant issues was determined, and it was used to schedule downtime to replace the blade. What it helped with is when you know that a blade is going to go down in 3 days, you can get all the necessary parts, you can get all the necessary equipment to replace it and schedule it, rather than it go down without any notice. On the virtual sensor side, some of the quality parameters on the quality assurance example, on the quality parameters like final humidity within a packaged product can correlate to longer shelf life. And based on the process that a product goes through, it uses the relevant data to estimate the quality of the packaged product without destroying otherwise sellable product, right? So it actually saves customer quite a lot of money to in testing, and a reduction of destructive testing on the product to establish quality. We have a success story with a customer where it resulted in savings of $100,000 by predicting when the product needed to be tested. And they determined that through the virtual sensing model, right? The LogixAI was streaming prediction. The streaming prediction calculates the probability of failure for the product that came by. If the probability was bigger than threshold, then they would test that product. Otherwise, they would let the product pass through. And this reduced their amount of destructive testing they did on the finished product by 79%. And that saved them $110,000. So how can you use this tool? Well, this is what I call a blank slate. You must know your problem, where you want to improve. As you would also know the variable of interest. What are your problems? What are the variables? You need to know the input and state variables, the boundaries and thresholds. Once you identify all of this, you plug it in, the LogixAI will take on from there. LogixAI will determine the relationship between the variable of interest, the input variables, right? It will cleanse the data, and it will get the data trained to the best level of confidence. If LogixAI cannot find the relationship, then other iterations would be needed. So what I mean by that is, you would need to have another set of variables. You would have to pick and choose the variables that would make the best sense. So in summary, I want to just say that you select on how making LogixAI work for your problem. You select the variable of interest. You select the problem that you want to solve. Right? You select the inputs and state variables that would impact your variable of interest. The LogixAI provides the data science behind it. It will automatically cleanse the data and determine the relationship and create a mathematical function. You send all the data you need to train that model to the highest level of confidence. And that is also automated in LogixAI's case. And basically use your automation skills to integrate that prediction into your controller program an application. Now you can either integrate it into the application, you can send out an alert, an alarm. It depends on you as a user. Okay. Please put in your questions on the screen. And thank you everyone for attending this seminar. If you have any questions, please put into your chat.
All right, thanks a lot, Niraj.
Hmm?